If you want a little more control on what is smoothed, and simple smooth is not enough, then Laplacian smooth will give you some extra options that you might find interesting. I have here a simple lathe. It is spun using the screw modifier. You can learn more about that modifier in the screw modifier lesson. The shape I've created, this wine glass, is basically a cylinder with two open ends. Let's add the Laplacian smooth modifier to the stack. The settings are similar to the simple smooth in that we can set a repeating factor, limit the effect to one or more axes, or isolate the effect to a vertex group. The factor setting has now been replaced by two options, a lambda factor and a lambda border. For you maths nerds, the lambda factor refers to the part of the smoothing algorithm which affects the roughness of the resulting curve. A low lambda value retains much of the detail present, whereas a higher value will average out all of the points to a combined average curve. The next two tick box settings are enabled by default, and they preserve volume and normalize the curve. I'll disable these so we can examine how they affect the overall result as we begin to tweak the other settings. Let's begin with repeat. Each level of repeat accumulates the smooth function. The higher we set this value, the smoother the curve becomes without changing any other options. We can restrict any of the smoothing to one or more axes. Think of adjusting the lambda factor as controlling the smoothness between each of the open borders, and the lambda border as controlling the smoothing only at the open borders on a mesh. When we enable preserve volume, the overall volume as described by the original shape is maintained. The normalized setting will take all of the settings so far and apply a normalize function to distribute that data. Isolating this modifier to a single vertex group is also an option. In short, the Laplacian smooth is like the regular smooth function, but with much more granularity to achieve a more desirable result.